What's up, guys? Welcome to Danger Person Code. In this video, I'm going to be showing you how to reverse a linked list. So, this question is an extremely common interview question, and speaks towards a person's supposed ability to think critically about the relationship between different discrete data structures. So, before you go into an interview, it's important that you have this question solid in your mind and add it to your arsenal, so to speak. So if you remember in the last video about linked list, I showed you how to construct a linked list as well as the class node that actually holds the data that is contained within the linked list. Then we also, as you can see here, we did a method for append, right, which works very much like the built-in append method for Python lists that just adds a value, in this case, a node with a value, to the end of the linked list. And then we also did a print method so that we could see all of our values that were added. So, and then we went down here and we created this. I created this list of numbers. I instantiated my linked list class into a linked list object. Okay. And then I just created a little for loop that iterated through this list and added uh, nodes with these specific values, right, to the end of the linked list. So the linked list just sort of grew one node at a time, each node being added to the end. And then when we printed this, right, in the terminal, we can see how all of these values, right, printed out in the same order, right, because they are added in this order, right, as the list here. And this has a connection to this. 7 right here. This has a connection to this, and this has a connection to this, right? Each one below the one above it is that node's dot next property, essentially. Okay. So what a list reversal uh, is all about is basically taking these connections, right, connections, the directionality of the connections, and reversing them so that when we print out these nodes, they print out in the complete opposite order. Okay, and that's how we'll know we've done our work properly. If when we print this after invoking our reverse method, right, these nodes are printed out in the reverse order because the directionality of the next connection between them has been reversed. Okay, so we can do this right in place. We don't need to create like a new list or anything like that. We can use the very same list that we've already instantiated. So we have all these methods already in place. Let's get started with the reverse list method. So the first thing I want to do is address some edge cases. So for instance, what if my linked list is empty? What if it only has one node? Reverse really doesn't make a lot of sense for an empty list or a list that only has one node. There's really nothing to reverse there. So we're going to check and make sure that there is at least two nodes in our linked list. Okay, so we're going to say if self.head is none, indicating that it's empty, or self.head is equal to self.tail. And if you remember, when self.head is the same as self.tail, right, unless they're both none, right? But if they're both pointing to the same node, that means that we only have one node in the linked list, okay? So if either one of these is true, what that indicates is that we have less than two, right? We either have 0 or 1 node in the linked list, and this method really wouldn't be applicable to anything we have going on in that data structure. So I'm then going to print out, right, just some little message here. This list contains less than two nodes. Okay. And then I'm just going to return false. Okay. Now that that's taken care of, if we have literally any other situation happening, the first thing that I want to do is I want to change the position of head and tail. So basically, when we reverse this list, the the head node, right, is going to become what the tail node is now. The tail node is going to become what we have currently as the head node. Okay, so we need to swap these. Before we do this, so that we can have a placeholder for our head node, we're going to make this pointer again called temp, and we're going to set it equal to self.head. Okay. And now that we have that place in the list saved, now we can assign self.head to the position of self.tail. Self.head equals self.tail. All right. And now we just need to move self.tail over to where self.head used to be. So let's take self.tail, set it equal to temp. Okay. So that's done, very least. Okay. Our head and tail have now swapped places. And we have this pointer temp, right? Pointing to where self.head used to be, but where self.tail is now. Okay. So just hold that in your mind. So now what I'm going to do is I'm going to make two more pointers. And temp and these two pointers that I'm about to define will move basically as a unit through the linked list, and they will reverse the connections. And remember, the connections are that dot next property. They're basically going to flip that connection to the node that is behind each particular node instead of the one that is in front of it. Okay, so the directionality of those connections will be flipped as these three pointers move through the linked list. And so we're going to define these two pointers that are going to be called before and after. Okay, so before and after are going to be set equal to none and temp.next. So before will be equal to none, and after will be equal to temp.next. And why we're doing this will become apparent soon, okay? But it's important that they initialize right there. So if we can think of temp as pointing towards the far left end of the linked list, where self.head used to be, but self.tail is now, before is set equal to none. So you can think of before as existing right before, right to the left of temp. And then after, you can think of as existing right to the right, immediately to the right of temp. So you have before temp and after. And like I said, these three are going to iterate through the list, right? And flip those connections. So here's what we're going to do. We're going to make a while loop. We're going to say while temp. And again, this is just us basically saying while temp is not none. I could do it either way. I could also use the length property if it exists, right? But like again, in an interview, you might not always be working with a linked list that actually has a length property. Uh, so while temp, right, is not none, or I could just say while temp, while it equals some value. Okay. We're going to do four things here. It's very important that we get the order of this correct. With each iteration, after will equal temp.next, which isn't really a problem, right, initially, because it's initialized to temp.next anyway. Okay. Temp.next, so this is where the connection will actually be flipped, right? So the next property of the node that temp is pointing to will become equal to before, right? So we're now taking that next property and we're reorienting it. We're realigning it to be connected to the node that is basically behind or to the left of the node that temp is pointing to, the before node. Okay. So that connection is now flipped. And then after that connection is flipped, we're going to iterate after up and we're going to iterate temp up. Okay. So the right way we iterate after up is simply after, then we'll iterate before up and we'll iterate temp up. Okay. Before and temp will be iterated up. Okay. Sorry about that. So before will be set equal to temp. And then we will set temp equal to after. Okay. And that's basically it. So this will move until temp these three will move in this way over and over and over again, flipping these connections until temp essentially just falls off the list, and then we'll stop. And at the end of this, we can simply return true. And so so if you can kind of visualize this, after we reorient this connection between temp, right, .net, when we make temp.next's connection, right, when we make temp.next equal to before, we're basically going to realign that connection, but we're going to leave a big gulf between temp and after, okay? So that connection, right, once we iterate temp up to equal after, right, that connection will be filled in essentially with this. This will fill in that connection, right, on the next iteration, if you can visualize that. But as you know, this might be confusing at first. It's much easier if you can see an animation, which I apologize I don't have to coincide with my explanation. But this is the code. This is the full reverse list method. Okay, so let's see how that worked out. So we have our print nodes right here. I'm going to reverse the list in between all of this. So my linked list, I'm just going to call the reverse list method on that. Okay. And what we should see is we should see these same numbers print out, but we should see the printout in the reverse order. Right. So let's see how that works. And there it is. 5 used to be up here, is now down here. 1 used to be up here, is now up here. And we have, as you can see, if you just want to compare it to the list, right, that we initially appended to the empty linked list, right? All of these numbers are occurring in the reverse order that they occur here because we reversed it. And if I comment that out, it goes right back to its original position. Okay. So before I go, let me just scroll up here and just give you one last look at the full reverse list method. All right. If you have any questions, throw them up in the comments. Feel free to like and subscribe, and join me in the future for more brutal, savage algorithms. All right.